Great. Thanks everyone for joining. My name is Roman. Should I stand over here? Yeah. I'd like to.
Ist knapp zum Logo.
Okay, sure. I'd like to present to you a customer case of ours, Ideoon, sorry, I'm always mispronouncing it. You may know it previously as Pearl.ch, but I will get into that. Disclaimer, sadly, Ivan from Ideon was not able to join us today because of personal health issues, so if you have any questions related to the applications, I can note them down and ask him afterwards, but I can't answer them today. This will be an EKS focused presentation, but I will also show you a lot of services you can use on top of EKS, so native AWS services. So I will give you an introduction later on. Good, so to the agenda, I will at the start give you a brief introduction to Ideon or Pearl.ch. Then I will show you the AWS infrastructure, so really basic introduction, not really detailed. Then I will show you the shared services environment, the challenges that we face during the development process and how we solved them. And then I will also give you a vision and roadmap update for this year. So at the moment we are in the process of migrating a couple of EC2 based services to EKS. So this is still in progress, so I will also give you some insights about additional services we used in the meantime. Great, so introduction to Ideon.ch, which is a mix of idea and vision, as I heard. So it's not Ideoon, as Marco said before, it's Ideon. It's an e-commerce shop. I think it's pretty popular in Switzerland, but I think a lot of people still use the old name because the rebranding was back in October. They have roughly 18,000 products and over 500,000 customers in Switzerland. And they started the Swiss expansion back in 1996. So the brand originates from Germany, and this is another company they launched in Switzerland 30 years ago almost. It's one of the leading technology retailers in Switzerland. You probably know the big ones, K8s and Digitech. So it's similar to these. You can see a screenshot of the shop on the right-hand side. And they gained strategic independence from the Pearl brand last year when they did a rebranding to Ideon.ch. We also supported them with the rebranding, of course. So a really basic overview of the AWS infrastructure. I think I don't have a laser pointer here. Do I? No. Okay. Yeah, no worries. I can point. So we have a control tower, landing zone, identity center setup, which is the default that we always deploy for all of our customers. It is well architected according to best practices and K8s. At the moment, I think they already have 15 accounts, which consists of workload and management accounts, so basic control tower setup. The most expensive services they use are RDS, databases, EC2 for compute, so not only EKS, but single EC2 instances, autoscale EC2 instances. They use Elastic Cache to offload some performance issues from their databases, as well as session caching, and they use simple email service a lot because it's a retail shop. They have to send newsletter emails, sign-up emails, billing emails, and so on, but I will come back to that. I heard they send around 10 million emails per month, which is quite a lot, so that's why the SES costs are so high. And they have had a steady workload increase for over 5 years on AWS. Oh, sorry, I'm drifting off to the right side. Good, so this is a diagram of their AWS EKS infrastructure. So on the left-hand side, you can see the shared services account. They use internal tools like Jenkins or GitLab for their deployment processes. So they develop, of course, a lot of code for the front and back end. Then they have a WordPress instance for documentation purposes and a Spring Boot application, which is used for different customer processes like newsletter delivery. I think they also host the CMDB on Spring Boot and so on. So as you can see, it's a mix of internal and external services. So all of you have deployed load balancers in the labs a few hours ago. So I think most of them have been internal load balancers. So there are also public load balancers you can reach from the internet. And if you have ever used WordPress, for example, you know that WordPress has an admin front end that should only be accessible by admins, not by the public. So using a combination of internal and public load balancers, we can restrict access and improve security, but I will also get to that later. Then you can also see we use WAF, so the web application firewall in AWS. It's also a native service that allows you to deploy or attach a firewall to, for example, a load balancer to improve security. We'll also give you more details about that. Then you can see RDS and Elastic Cache in the middle. So we have a lot of instances, of course, for different purposes. And we have the big icon SCS for centralized email delivery. So there are multiple workloads accounts that use emails, and we have centralized that in the shared services account. Then in the middle you see the workload account, which hosts the front end as well as the back end of their main shop infrastructure. And you can see that we also leverage CloudFront, which is another AWS native service, as a CDN, content delivery network, to improve performance as well as security, because CloudFront can cache a lot of requests that frequently come into the shop. It makes the shop a lot faster, and of course reduce the traffic to the back end. And on the right-hand side, you can see the planned infrastructure for 2025 that we're working on. So we're working on offloading native EC2 services to EKS in the next couple of months. But I will also give you some more details about that. Good, so regarding the workload account, to improve shop performance, we have offloaded all images that are used in the shop to CloudFront and S3 setup, which basically allows the browser to fetch all images, not from the application itself, but from a different or outsourced CloudFront setup. Then we have the front end hosted for the newsletter on an S3 bucket using an Angular application, and the back end of it is hosted on EKS and is also leveraging SCS to send all the emails, the newsletter emails. And finally, billing access. So, for example, if a user wants to access his latest bill for his latest purchase in the shop, we have used signed URLs for CloudFront to restrict access to these private documents using signed URLs. So only the customer that has access to the specific URL string is able to access his billing details, nobody else, compared to, for example, the images which are publicly available. Yeah, the shared services environment. As I already mentioned, they use GitLab in combination with Jenkins for development purposes and deployment purposes. We have implemented custom solution using Event Bridge, which you can see on the bottom in the middle, to automatically trigger restarts of deployments in EKS whenever they push a new release via Jenkins. Then I already mentioned that they have a shared SES identity in the shared services account that can be used by each workload account to send emails. The EKS cluster is using a self-managed Carpenter solution, which is doing all the auto-scaling of the nodes depending on the load that we currently have on the cluster. And then we have internal as well as external load balancer for different purposes, depending on if it's a public service or a private service. And finally, we have different web application firewall rules to further improve security and restrict access. Good, then I'm already at challenges and how we solved them. So as I said, we are already working or have been working for over 5 years on the setup. So there were a lot of challenges we faced and we had to solve them using AWS native services. For example, I already mentioned that as well, security topics like CloudFront, web access firewall, load balancers. Then I will give you some insights about SES if you ever plan to use simple email service from AWS. There are a couple of things you need to consider. Reputation, I will also get into that. Then I will give you some insights about the access management that we implemented. Another important topic, budget and monitoring. If you have an auto-scaling EKS cluster, you should also closely monitor your costs because, of course, depending on load, your cluster can scale and then the costs can also increase. Then I will show you how we improved performance of the application, and lastly I will also give some insights about CloudFront caching. Good, so first off, security. So the big topics in the Ideoon case are CloudFront. CloudFront, as I said, is a content delivery network service by AWS. It allows you to cache frequent requests depending on policies that you can specify. You can even put a web application firewall in front of CloudFront to even further improve security. You can leverage AWS Shield for DDoS protection, which is natively integrated with CloudFront. Then, of course, you have TLS and SSL encryption. And I already mentioned that as well, signed URLs to restrict access to certain files with specific URLs that are only exposed to the user that needs to have access to the specific file. Then web access firewall, we have used a couple of AWS managed rule groups, which I can recommend. So AWS provides managed rule groups that you don't need to further customize, that they work out of the box. And I think all of the ones that I mentioned here are free to use, so they don't have additional costs, except for the traffic costs, of course, but no additional costs on top of that. The most important one is the IP reputation list. It allows you to automatically use an IP list that is frequently updated by AWS with malicious IP addresses. So all these, let's say, IPs from North Korea, for example, are automatically tracked in this list and are blocked whenever you use this managed rule group. Then we use the core rule set, which prevents your application from several known exploits like SQL injection and so on. Then there is a bot control managed rule group that protects your application from certain bot performance issues. And there's even a WordPress managed rule group that protects you from known WordPress exploits. And of course, you also have the option to implement custom rules, which we also did. So to restrict access, we have, for example, created an IP set that only allows access from on-premise IP addresses. That way, the application is protected from public-facing IP addresses except the ones that are originating from the customer's office, for example. Then the next point, how we handle SES reputation. So simple email service by AWS comes in together with a reputation that you have in your account. So with each identity that you have also a reputation, and if the reputation falls below a certain threshold, your identity will be blocked. So AWS will not allow you to send any more emails. So that is something that you need to prevent in any case, so you should always monitor these reputation metrics. So for example, if you always send emails to addresses that are not available anymore, these emails bounce, and if the bounce threshold reaches a certain limit, you will be blocked. That is of course implemented by AWS to prevent spam. For example, if someone has malicious intents and uses SES for these purposes, he will be banned sooner or later. Then in the initial phase of the newsletter rollout, we throttled the emails, so we didn't send 500,000 emails in the first couple of days. We ramped it up to see how the reputation develops. Then there are feedback notifications and configuration sets you can enable for even more debugging purposes. So if you have bounces, you can see why the email bounces. If complaints come in from users, for example, if you right-click on an email in your Google account, you can complain if something is sent to you without your consent or advertising that you don't want. And the customer also has implemented a process to automatically update the suppression list, which prevents emails being sent to email addresses that are not available anymore. Good, then the next point is how we handle access management. I already touched these points, so it's a mix of internal and internet-facing local answers depending on the service purpose. Then we have put web application firewall IP sets on top of these ALBs if necessary, if you need to further restrict access to our applications. Signed URLs, I already mentioned that as well. Then we have a networking hub in the landing zone. This is a dedicated AWS account, which consists of a transit gateway and a side-to-side VPN connection to the customer. This allows the customer to access his private resources in his account via a VPN connection. So, for example, the K8s cluster that you used in the labs had a public control plane, so you could theoretically access it from anywhere in the world. Normally, we deploy all our K8s clusters fully private, so you can only access the control plane and execute kubectl commands if you are connected to the networking account, which of course improves security by a lot. And then I already mentioned that as well. We have custom web access firewall rules to restrict, for example, access to WordPress admin. If you have ever used WordPress, there is a /admin path that allows you to gain access, full access to the application, and these paths are, for example, restricted using firewall. And I already mentioned, fully private K8s cluster, so you can only access it via a client VPN or side-to-side VPN connection. Good, then budgets is a really important topic, especially if you use K8s, because EKS can scale normally depending on the demand or capacity demand of your application. At K8s, we use the AWS Cost Anomaly Protector, which is a new service, I think it was launched last year, 2 years ago, or 1.5 years ago, something like that. It basically scans your AWS account for service costs that increase by a certain threshold. So if you, for example, pay $200 a month for EC2 instances for your EKS cluster, and suddenly it skyrockets to $400, you will get an alert from the Cost Anomaly Protector. Or detector, I think it's detector, it's a typo, sorry. Then we have set up multiple budget alerts. So budget is also a native AWS feature that monitors your AWS costs, and you can configure emails being sent if the budget reaches a certain threshold. We have even multiple different budget monitors there with forecasted budgets and actual budgets. So we get multiple alerts if any costs are outside the order. Then we are using multiple different SNS topics for different kinds of alerts or events coming from our AWS accounts to easily see what service or what type of event was causing these notifications. And another important topic, in your AWS account, you can always configure so-called alternate contact details, which allows AWS to contact you in case the default contact information is not reachable anymore. We had a customer incident a couple of years ago where the credit card expired, so they were not able to pay the bill anymore. And if you don't pay your AWS bill, they don't wait too long until they terminate your account, and you basically lose all your applications at once. And using alternate contact details, they still have a way to contact you to inform you that you need to fix your credit card information, for example. Good, and how we improved performance. As I already said, we offloaded all images, which of course cause a lot of traffic to the front end, to a dedicated CloudFront S3 setup. Then we store the user session data in an Elastic Redis service, as well as frequent SQL queries are also cached using Redis. Then we also use CloudFront caching on top of the ALB to reduce the amount of requests going to the origin. So if, for example, the front page of Ideon is always the same, and to prevent every user from accessing the backend or the front end to load this page, CloudFront can cache the home page automatically and immediately serve it to each user, which improves the performance by a lot. Then we have Carpenter for auto-scaling. I will get into that with a little bit more detail on the last slide. And we use RDS Aurora Serverless V2 for database scaling. So another native AWS service that allows you to provision, for example, a Postgres database that automatically scales with the demand that you have. So the more users you have, the more requests the backend, and the database scales automatically. And it also scales down, of course, if you don't have traffic coming in. Good, then how we handle caching, that's a quick one. So we use AWS CloudFront, and in CloudFront you can specify custom policies regarding caching. So you can specify which paths or which files are cached for how long until another request to the origin is being made. 3 minutes, yeah, I'm almost there. Vision and roadmap for 2025. I briefly touched this topic. We are in the progress of migrating the EC2 workload to EKS. For that, we will introduce EKS Auto Mode, which is a new EKS feature that launched last year in November, I think. Basically, it provides you with a fully managed EKS cluster, including Carpenter auto-scaling and the most popular EKS add-ons that are managed out of the box by AWS. So you don't have any management operation effort you have to put into EKS for that. It scales out of the box and all the controllers are already there. In the last presentation, George and Jan showed you Flux, so we will also introduce Flux for Ideon to automatically deploy their application onto EKS. We leverage customized Carpenter node pools. If you have used EKS Auto Mode already, you may have noticed that EKS Auto Mode uses on-demand EC2 instances, which are pretty expensive. So normally we introduce a custom node pool that uses spot EC2 instances, which are a lot cheaper. And lastly, we will also introduce an image building process using AWS Code Pipeline and Code Build. Whenever they create a new release of their shop application, we will build a new Docker image and upload it to the internal ECR registry. Yeah. I made it. I mean, I have 1 minute left, so we have 1 minute for Q&A. But of course, you can also ask me after in the upper.